Good day, everyone, and welcome to this joint webinar hosted by AWS and Univa. Today, you have myself, Terry Fisher, speaking. I am the Business Development Manager for HPC for AWS. Joining me today, I have Rob Lalonde, Vice President and General Manager of Cloud at Univa, and Bill Bryce, Vice President of Products. Today, we're going to be telling you how easy it is to extend your on-premise Univa HPC system to AWS and running through a demonstration showing you how the system will work. But first, a little bit about AWS and how we are addressing the needs of HPC customers. First slide, please, Bill. AWS has an extensive global infrastructure available to our customers. All of the locations you see here are capabilities and resources that we have available for our customers. It means that resources are never far away. We can always place capability very close to where our customers require them. Every location you see is actually 3 locations within a region. So every town, every city or location you see here is a region. Within that region, we have at least 3 availability zones. So wherever you see AWS as a location, we're actually there a minimum of 3 times. This ensures that we have availability within a region and we can serve our customers effectively. Next slide, please. So why HPC on AWS? We have that global scale and global reach, as I mentioned previously, so it does give access to virtually unlimited compute resource when you need it. This allows you to be more flexible in how you consume HPC resources and allows you to tackle some of your challenges around time to market and backlogs. Cloud also gives you access to a variety of different technologies, and they're available almost instantly. So experimentation with new machine types, new technologies, new architectures becomes very quick and easy to implement. You can experiment quite easily. It also means that you potentially avoid needing to actually go and buy more physical resource to serve a temporary need. The flexibility of cloud also is another key aspect. So infrastructure in the cloud is not of a fixed size, so it gives you the flexibility to grow and shrink your environment based on your demands and try to optimize your use of cloud based on matching consumption to demand. This ultimately delivers better return on investment of infrastructure because you're not over provisioning, and if you're under provisioned, it gives you the ability to get to results faster because access to additional resources will mean a faster time to results. Next slide, please. So as I mentioned, the metric for success with HPC, when you're looking at HPC on-premise clusters and cloud together, is breaking the restriction on finite capacity. This means that whilst you're going to leverage your on-premise HPC to its maximum, you also have the ability to extend the capability with cloud to deal with peaks and troughs in terms of additional demand placed on your HPC by your users. This additional capacity can make a significant inroad into making sure that your backlog doesn't get to the point where it's now affecting your time to market. Next slide, please. So, and this is borne out with some research that we've conducted that states that many organizations have actually delays to their HPC or have actually had to cancel HPC workloads just because of a lack of resource. This then affects productivity and overall time to results, as I've mentioned before. It also potentially stifles innovation because it restricts your ability to experiment. You know, can we try running a different model? Can we try running a larger model? If you're resource constrained, then those kinds of experiments become very difficult. So cloud can unlock experimentation for your engineering design teams. It also provides you access, as I mentioned before, to some of the latest processor, GPU, and networking architectures, so that you can exploit the technology as it becomes available, rather than kind of waiting for a procurement cycle to get at the technology that potentially, when you get to it, has already been out in the market for a year or so. And ultimately, this helps you kind of retire some of that previous technical debt and match infrastructure needs to compute demands much more effectively. Next slide, please. So this is kind of an example of how this is borne out by one of our own internal examples. AWS actually designs a lot of AWS infrastructures, supports the design of a lot of Amazon products. One of those product life cycles requires a large amount of compute, but just for a short period of time. So we were able to complete a workflow in 44 hours instead of 41 days because we had access to additional temporary resource. This has a massive impact on time to market, and is a really good example of why bursting to the cloud can make a lot of sense when you're under resource constraint and time pressures. So you can see the decision ultimately as to how to deal with the workload was made at the start. The shortening of this decision cycle has gone from a significant kind of, almost over a month to decision in less than 2 days. So by accelerating this simulation, by getting the job done much more quickly, the decision about whether to go to market or not was made, in 48 hours as opposed to 6 weeks or more. Next slide, please. So we have a range of capabilities that are designed specifically for HPC use cases. I'm not going to dive into all of these individual services, but ultimately what we have here is a set of capabilities that allow us to build a very capable and very powerful HPC system on demand in the cloud. We have a set of tools to help get up and running quickly, and we have a lot of integrations with our key partners that make going to the cloud possible as well. And that's a key thing that you're going to see just a bit later on as part of the demonstration. Next slide, please. So as I mentioned, we have a broad and deep range of capabilities for HPC, a very broad range of different compute instance types. So we can be very clever about matching the needs of your application to the right instance flavor within AWS. Safe to say, again, not to go into too much detail, but typically there's a very good match between what your application needs and the type of machine that we can provision to support that. Next slide, please. And most importantly, we can't do what we do in HPC on AWS without our partners, and Univa is one of our key partners, enabling and making HPC that much easier for customers to adopt. Next slide, please. So ultimately, in summary, before I hand over to Rob from Univa, AWS is about flexibility, it's about scale, and it's about being able to support or supplement your on-premise resources with temporary cloud resources to keep you on track, to maintain your time to market, and ultimately deliver results back for your business. And with that, I'm going to hand over to Rob Lalonde.
Thanks, Terry. Appreciate it. I love your Tetris slide, by the way. That's pretty interesting the way it demonstrates how you can get a lot more work done in a shorter period of time, and that's important to everyone, I think, in our customer base. So Rob Lalonde here, as Terry mentioned, with Univa. I'm responsible for the cloud operations. Univa is a workload management vendor and cloud migration company. A lot of people know us as the Grid Engine company. We've been doing that for over 10 years now. And the last number of years, we've been spending a lot more time in the cloud as well as on-premise with our customers. Our focus is enterprise scale, modernization of compute infrastructure with things like containers and GPUs. We've established a base of about 250 enterprise companies. About 85% of those are Global 2000 household names. You'll see some of those in the next slide. And you can see that a big focus of ours is scale, whether that's support of a broad set of applications. We sit on a very large set of cores, 3.3 million cores on premise, in fact. We support 8 million jobs a day with some customers, 500,000 core clusters. And in fact, we've gone as far as to build a 1 million core cluster with Amazon that I'm going to speak about. Our customers come from a number of different industries. We have a real strong leadership position in life sciences. You see that in the middle there. We've got 7 of the 10 life sciences companies as customers, 7 of the 10 largest life sciences companies, I should say, and over 60 overall in life sciences. We've got a strong EDA base, and we have 2 of the 3 largest EDA ISVs. We've got some world-leading oil and gas organizations. We've got about 25 of the major airlines. So just to give you a flavor of the verticals we play in, regardless of whether you're a large company or in one of these verticals or not, I think we've got solutions for your workload management and cloud migration. And you see those now with our product slide. So Grid Engine has been our mainstay product for a long time. Customers use that to do the workload placement based on policies. We're all about really efficiently utilizing that hardware and about getting the right work done for the right people at the right time. Our customers run in excess of 70 to 90% utilization on their clusters. So really, really efficient utilization of these major hardware investments. And NavOps Launch is now extending those customers into the cloud in a very seamless fashion and works alongside Grid Engine to do that. And we're going to talk about NavOps Launch a lot more and demonstrate that as we go forward. So we've been engaging with customers for 3-4 years now in total on the cloud, and we had an early product a number of years ago. We didn't see a lot of adoption, but over the last 3 years, we've seen a big shift. And if you look to the right-hand side, you can see 61% of our customers now are either open to cloud or in the process of migrating or have already migrated to the cloud. So it's a big shift from 3 years ago where we only saw a handful of customers with an interest in the cloud or activity in the cloud. Of the ones that know their plans or are deployed, a full 70% of those are hybrid cloud, and 30% of those want to do a dedicated cloud-only cluster. And in actual fact, there's an intersection between those two numbers, because customers that run on-premise and want to do hybrid also want to do some dedicated clusters for special purposes. And in almost every case where we have a hybrid cluster, hybrid customer, they also want to do some type of dedicated cloud work as well. So they end up with this multi-cluster scenario where they're bursting their on-premise cluster and they have a cloud-only dedicated cluster or clusters for special purposes. Used to be a lot of inhibitors, things like cost, security, capabilities in the cloud, and cloud skills within the customer base itself. Those have fallen away now. We're seeing a real shift. And if you look at the drivers on the left-hand side, bursting for peak workloads is probably number one, and we're going to show you some examples of that. And Terry's already done so with his Tetris slide, where it's really all about right-sizing your on-premise infrastructure to some normalized amount of workload, and then taking the peaks off that cluster and getting more work done when you need to by bursting for those peaks into the cloud. And that's what a lot of our customers are being driven to the cloud for. We also see customers being driven to the cloud for new technology, things like GPUs, or big memory machines, SSDs, things like that, where they're going to go to the cloud for specific applications. We do see a top-down mandate to use the cloud coming at it very much more from a financial perspective. We see customers wanting to get out of the data center business entirely. Makes a lot of sense. And as I mentioned earlier, we see a lot of customers wanting to go to the cloud for special projects. So the 1 million core example with Western Digital that I'm going to talk about is a great example. We had a customer recently that had a data set on the West Coast and a data center on the East Coast. The data set was a genomics data set in the cloud. It just made a heck of a lot of sense to run that workload in a dedicated cluster on the West Coast with Amazon versus trying to run that on their East Coast data center and move that very large data set. So Western Digital, I've already mentioned, this is a project we did with Amazon. It was a very massive scale, complex multi-physics simulation for some next generation products that Western Digital wanted to simulate. We built this 1,000,000 core cluster, just over 1,000,000 cores, in just under 90 minutes, ran 2.5 million tasks in under 8 hours. And you can see really how you can achieve more with the cloud or with the on-premise plus cloud. And in this scenario, the customer achieved something that normally took 20 days in 8 hours. So ultimately, that leads to time to market, as Terry mentioned earlier, and that time to market leads to competitiveness, more revenue, and improved profits as well. Wharton School is another great example of a customer that's doing cloud bursting with Univa solution and Amazon. They have a lot of diverse and research and analytic workloads coming from a lot of different users within the school. They had a fairly small on-premise cluster to start with, and they just weren't achieving what they wanted to achieve for their faculty, staff, and students. They also had decommissioned some older GPUs, so they no longer had access to GPUs on-premise. So what they did was they used NavOps Launch to burst to AWS. That gave them access to GPUs when they needed them, lease them versus buy them. And what they ended up with was a set of cloud infrastructure that was very composable, operated in a no-ops fashion, burst to the cloud when they needed to, shut itself down when it wasn't in use, and it gave them many times their on-premise infrastructure at certain periods, so that when they were bursting, they had 4 or 5 times what they had on-premise, and when they weren't that busy, they just scaled right back down to just their on-premise infrastructure, which I mentioned was a fairly small cluster. So this really gave them an optimal financial model to optimize their on-premise investment, get access to expensive hardware like GPUs, and leverage the cloud when they needed to. Life sciences. This is a top 10 life sciences company that's just wrapping up their implementation with us right now, so we won't get into the specifics of who they are, but they have an interesting model because they're doing all-in cloud. So they have over 20 clusters for different business units, whether it's genomics or molecular modeling, et cetera, or different regions. And we build out all of these clusters as infrastructure as code. So essentially, you can press a button to create a cluster, and the cluster is completely created from code and policy. Those clusters each scale automatically using the automation rules that Bill's going to talk about shortly. And it's just a great example of a very dynamic, composable no-ops environment. In this case, not a hybrid cluster, but dedicated in cloud. So before I turn it over to Bill to give you a demonstration of NavOps Launch in action, I just very quickly on the architecture of NavOps Launch. You can see NavOps Launch here with Grid Engine operating in the cloud. A very important element of this is the reporting database on the bottom right that you see. That's a shared repository between Launch and Grid Engine, where all of the cluster metrics and cloud metrics reside. That gives us the ability with this automation that Bill's going to show you to use a lot of intelligence in our cloud bursting policy. So if Launch can see what Grid Engine is doing when queues are getting busy, when jobs are waiting, when a user's submitted a specific GPU workload, those kinds of things, Launch can act on Grid Engine's intelligence and vice versa. So that reporting database becomes very important and a central sort of repository for all of the activities that the automation that Bill's going to show you drives. And that's how we achieve this no-ops model, the cost savings driven by the automation. And it's just a great example of how the product leverages the automation. You can see the major components. There's a web UI that Bill's going to show you. There's the automation engine itself, where you get pre-canned policies as well as build your own policies for how you want to manage the cloud. There's the cloud management capabilities for doing the provisioning and configuration management. And then there's the data management and metrics database itself, which I've already spoken to. So Bill's going to now demonstrate to you NavOps Launch. He's going to show you both a seamless hybrid cluster that's bursting to the cloud, as well as a standalone dedicated cluster or two right through the same UI, and we'll show you how you manage that, and we'll show you a little bit about the automation elements of that as well. So with that, I'll turn it over to Bill.
Good afternoon, everyone, and thank you for joining the webinar. So let me switch over to the software and start the demonstration. So before I begin, I'll use a story, and Rob has already given you sort of a use case from one of our customers to represent a typical Univa customer in the life science space. So I'll give you a little bit of background because that gives you more of a level set so you understand where we're coming from. In our life science customers, so they typically have very large computational problems that need to be solved in the process of analyzing compounds that may be good candidates for future research. A good example is computational chemistry. It's particularly demanding and may even be as sophisticated as quantum mechanics modeling, such as the chemical, physical, and energy interactions at the quantum level. So as you can imagine, this is very computationally intensive. So they may need to borrow or extend their cluster environments as the other presenters have described. So using cloud resources makes sense. So let me just log in and start this process. So during the demonstration, there's quite a lot of what's going on behind the scenes in automation. I will give you some background so you know what's happening because a lot of it is underneath the covers and you don't quite understand what is happening. So I'll go back again to the launch screen. This is really the login, the single sign-on portal that can be integrated into standard IT authentication mechanisms. And let me log in again. So you can connect it up to things like Microsoft ADFS or LDAP, or connect it to the services within Amazon that manage identity management. So we're using OpenID underneath the covers in the portal, so it can connect to many different types of authentication systems. And as you can see, once you log into NavOps Launch, you're presented with a summary dashboard of the clusters that are under management by NavOps Launch. In our example, there are more than one. There are 3 clusters here, and I have a US Central Sequence cluster and a US Sequence hybrid cluster. A hybrid cluster is, as the name suggests, it is a hybrid cluster that has some on-premise nodes with CPUs and some in the cloud. In fact, the way we do it right now is that the nodes that you see here are only the ones represented in the cloud, and so they'll only be used when the on-premise cluster is full, or as an example, if the customer wants particularly specialized hardware needed, such as GPUs that are only available in the cloud. We're typically managing only the cloud nodes in a hybrid cluster. The on-premise nodes are managed using your standard IT processes. That's a choice we made because customers have very much decided upon how they're going to manage their on-premise environment. So what we're doing here with Launch is just extending that to manage their hybrid nodes in the cloud. So let's get a better idea of how this works. So from that, as I said, you've got 3 clusters here from the screen. We are interested right now in the US Central Sequence cluster. And you can see this cluster has several nodes in it, and there are 3 donuts here which represent different states of the system. The node status represents, how many nodes are in the cluster, and of course green meaning good, which means they're up and they're operating properly. The nodes have 2 different node types, which represent the role that each node performs in the cluster. And so, of course, in a real HPC cluster environment, nodes have different roles. I mean, you can see here that I have 2 compute nodes and one which is the scheduler. And so 2 nodes can actually perform work, actually run jobs or run applications, and one is responsible for scheduling work in this cluster. In fact, it is the Univa Grid Engine scheduler. Finally, the last donut represents different cloud vendor configurations used in this cluster. Again, I have 2. One for the scheduler, which is actually the default one. And then you can see here I've got a profile which is a T3 medium, which represents AWS T3 medium instance types. Now, you can create other types of nodes with different instance types. You probably wouldn't use T3 for really computationally intensive, but for this demonstration, it's a good place to start. Now, with that in mind, you're probably wondering, okay, so how did I create those different configurations so that I can launch different instance types? And that's what those cloud connectors are. As you can see, I have an AWS cloud connector, and then underneath it, there are different profiles which represent different configurations for that particular cloud vendor. All the profiles listed here are for AWS, and adding a new cloud connector profile is pretty easy because the system has defaults built in. In fact, I could go over here and create a new one, and we'll call it like P3, like Nano or something. I don't know if I can't remember if this is a correct profile name, but then you go over here and you change the configuration. You can see that it has taken all of its defaults from this default one up here. And so all I'd be changing is down here and saving it. And really, that's typically all the things you need to change to get a node to a new type of instance type running in the cluster. Now, these are on-demand instances, but you can also set up NavOps Launch to use spot instances. I'm not going to show it in this demonstration today, but it is functionality that is supported by the software. So moving back to the cluster summary, we'll talk a little bit about the other items you can see here across the top. You can see that there's status, there's automation, node list, and monitoring. So the status is the donuts. I don't have to talk about that. I've already explained that. The node list represents really a list of nodes that are in the cluster, their current status, the software that is really on them, and the profile that is attached to them. Sometimes people want to add things manually, and you would do that here. I mean, if you, for example, as an administrator, because this UI, as you can see, is really designed for an administrator, not typically an end user. They would go in here and create, say, for example, an M4 extra large, and I want to make it a compute node and how many I want, and then I would add it. I'm not going to add that right now because I already have enough nodes in my cluster. But that's how you manually add it. But the more interesting part is in the automation. The automation tab is where you configure the system to make decisions to do something in the cluster. It's pretty straightforward. It's a if this, then that type automation engine. You know, if something evaluates to true, then do something. And you can, of course, perform pretty sophisticated actions based on that simple concept because you can chain these things together. You can make more complex automations out of it. So behind the scenes in my cluster environment, as you saw here, I have a Grid Engine cluster. That's what this is. It has its own scheduler, as you can see here, and 2 compute nodes. And there is actually work behind the scenes in the cluster right now pending. So I did it this way, so it's much easier for me to show you how the system works when I turn on the automation. So let's do that. We'll turn on the scale up pending, and we'll turn on the scale down empty, and I'll manage that. We'll save it. All right. So this US Central Sequence Cluster this one's a cloud-only cluster. It grows and shrinks as needed to meet those genome sequencing demands of the scientists. So it doesn't need to be there all the time. Just grow and shrink as needed. And many of our customers create these, for different groups and different types of applications because they can use readily available public data that may already be in the cloud for their analysis. So when you put all these pieces together, it's quite easy for customers to create these clusters, use data that's already available, and then we really are just providing the end users access to the cluster either through an application tool or even as low level as them SSHing, remote connecting into the nodes and submitting their jobs into the scheduler. So there, as I saw here, I turned on these automation rules, and in fact, you will see that a couple of things already happened. First of all, let me describe what they do here. The scale up pending automation really looks for a special label inside Grid Engine. And I'll explain how this works. So Rob talked about how the system is tied together with Univa Grid Engine. And in Grid Engine, you can add labels, much like you can add labels in Amazon AWS, to your work as you submit it into the system. And those labels can identify, this is a job that can go to the cloud, or this one requires lots of memory, or it may even require a particular instance type, or something like that. And then the automation engine can use that to make the decision. So in this case, I'm looking for this special Tortuga resource name. And if I see that, then what will happen is this automation rule will evaluate to true, and it will connect to AWS, and it will fire up a T3 medium node. And once that T3 medium node is up and running, it will join the cluster, and then jobs will be dispatched to the cluster. And so you can see things were already happening down below here, in fact, with this event window. Now, the scale down empty automation is even simpler than the scale up. And so what it does is it's currently hard-coded to evaluate the normalized processor load. And normalized processor load really means it can tell you whether the machine's busy or not. And if it's below this 0.10 value for 3 minutes, then this node is a candidate for removal because it's considered idle. So together, these two automations either add nodes or remove nodes to the cluster as needed to handle the workload that is submitted into the system. So I already turned on the automation. In fact, it actually added nodes, and you could see too that some of these nodes were idle. So it deleted some of the nodes as well. In fact, if we go to the node list, you'll see that. So it actually ran the workload, and the workload has completed, and it's now shrunk the cluster back down. So in our sequence cluster, what happened was the jobs ran to completion. NavOps launch automation automatically triggered and removed the idle nodes. It happened pretty fast. You probably missed most of it. So, but if you look down here at the bottom, you'll see that it actually added nodes, ran some work, and then there wasn't a lot of work left over in the cluster. So it actually deleted all the nodes that were idle. And then the jobs had finished. So let me just review what I just demonstrated to you so that you sort of get the highlights, the points that are important. First of all, I mentioned that NavOps Launch uses OpenID on the login screen, and it can connect to LDAP, OAuth, ADFS, or other authentication mechanisms. We can actually connect it to one or more cloud providers. As you see here, we have an AWS cloud connector. The overall architecture is pluggable, so we can actually support different providers quite quickly. There are those cloud provider profiles, which really connect our system to the particular cloud. And these here, as you can see here, are the cloud vendor specific parameters. For example, which AMI to use. That's completely customizable. You could use a stock AMI from the image from AWS, or you could create your own image, use that in the cluster. So you can customize what happens to nodes as they bootstrap. You can customize the networking and security group that they're in. So it's very flexible from the perspective of how you build these cluster environments. Nodes can have let's go over here to, nodes can have a software profile. That's what this is here. This represents sort of the personality of the node. Is it running Grid Engine? Is it a compute node? Things like that. And you can actually create one or more clusters by going here and creating a new cluster. For example, let's call it There's new. And I add a new scheduler. And we'll add a couple of T3 mediums. That will actually go off and create a new cluster pretty much as we are talking here. And once that new cluster comes up and everything is provisioned and the configuration management system has triggered and everything's running properly, then essentially you log into the cluster and start running your workload. You can see that it's already gone through the process of starting to create the cluster. And you can see that they are coming up. Much like in AWS, we have the state where they come up, and then eventually they become installed, and that's when the cluster is ready to go. Okay, so that's pretty much it for demonstration today. And we're moving on to any questions that people may have.
So Terry, back to you.
Absolutely. So I have a few questions that I'd like to ask. So the first question is how you manage data when you're spreading your on-premise environment to cloud.
So data is managed using that automation engine, the policy engine that I described. And because the policy engine is using metrics and data directly from the Grid Engine cluster, you can make your decisions based on the job itself. So it can look at the job and decide that it requires data. And then what happens is the data is moved before the decision to move the job to the cloud is made. So typically what we do is we use a tool like rsync, or we use AWS Sync or some other data synchronization tool to move the data before the job starts. So it's a separate step. And then once it's in the cloud, then we send the job over and actually run it in the cloud.
Yeah, thank you, Bill, because that's really important, because it means that you're not having compute resources spun up in the cloud and idle while you're then spending time transferring data out to the cloud. It's very good to have that separation. Thank you. The next question I have is, I think you covered it in the demo, and that's how do you choose different instance types? You mentioned the different families, and this touches on a question that we've had from one of the attendees as well, which is around GPUs versus CPUs. As you may have seen, AWS compute ultimately is based on families of compute profiles. So something like GPU is found in our P series family, and that would have the different types of architecture available. And I think, as you saw from Bill's demo, you can choose the family and the instance flavor quite easily from within the console.
Yes, that's correct. So you create
that was
a new
question that we have from Yes, go ahead.
We create a new cloud connector profile. So if you saw that in the UI, and really you're only overriding the things which have to change, which in that case would be the instance type.
Okay. The next question was how you manage the kind of the determination of where a job executes, and I think you highlighted that quite well, Bill, around using a policy ultimately to make those decisions for you.
Correct. You use the automation engine, the policy engine, to make that decision on which jobs that are in Univa Grid Engine Scheduler are candidates to go to cloud and which are not.
Okay, excellent. And the last question I had was, how could a customer actually try out bursting from their Grid Engine cluster?
Yeah, so that's a great question, Terry. We can certainly help those people out. If you want to just come to our website and express your interest through the web forum for NavOps launch, we'd be happy to engage. We'll bring our Amazon friends with us for the ride, and yeah, we'd love to do a POC. And I think Terry, in some cases, can even offer up some credits to make it a little more palatable from a financial perspective. So I think that's the best way to go about it.
Okay, and yes, to back up what Rob said there, AWS in certain cases is prepared to put forward credits for a customer who's experimenting with bursting to the cloud or trying out the cloud for their HPC. We do it on a case-by-case basis, but it's not an arduous process, so it's something that we can typically make happen quite quickly.
Fantastic.
Okay,
well, thanks, Terry, for hosting us.
I think we may have a few more questions. Yes, I think we may have a few more questions from the audience. I'm just waiting for those to appear in the panel. If you can bear with us just a moment, we're just waiting for those questions to be shared.
Okay.
Okay, so one of the questions is, how do you tag the instance types, and are there cost analysis tools built in?
So what was the question?
Sorry, the question was, how do you tag the instance types, and are there cost analysis tools built in?
So when in that Cloud Connector profile I had in there was a section where you can add additional tags, which are AWS specific tags, so that it can be used later by a cost analysis. For example, like AWS Cost Explorer to figure out, which particular instances were launched and how much they were used in the system.
Okay, thank you, Bill. Okay, the next question I have is, how does the system decide which data to copy? Does the job have to specify that?
Yes, sorry, when you're submitting your job into Univa Grid Engine, you specify, this is a pretty standard thing in Grid Engine, you specify where your input files are and where your output files will go. And we've added additional parameters to that submission. So you tell it that the job needs to be synchronized, and the data needs to be synchronized. And so it will copy from wherever you pointed the directory into typically a shared location in AWS, so that when the job runs on an instance in AWS, it can get to the data and do the computation.
Okay. How are the images for the nodes done? I think I'll take that question. So this is something that you would prepare within AWS, within the AWS console, to build what's called an AMI, an Amazon Machine Image. This is where you would start with a base AMI flavor, or Linux or Windows base, and from there layer on the different files, libraries, applications, tools, and whatever else that you'd want to then make as part of your image. You then package that up into an AMI, and then that has then a unique reference. And from within the Univa console, you can then call up that AMI as what gets deployed on the machine when it gets provisioned.
Right, and I can add a little more to that. So when people first start using a product like NavOps Launch, they may not be quite sure which applications, tools, libraries, and things they need in their image in order to run their application. So you can do it in a multi-step process where you start with sort of your blessed stock image from Amazon, and there NavOps Launch does have configuration management built into it, so it can put additional RPMs and packages onto the machine once it comes up. And so that would be like your first step. So you've got it to the point where you understand which additional packages are needed, and then things are running. And then you do exactly what Terry said. Then you create a new image with all from the base image that has all your software installed. So it's much faster next time you run.
Excellent, thanks, Bill. The next question is, have you had issues with the licensing of applications? Do you need to have a license connection back to your in-house license server? I'll take that one. It will depend on your licensing setup, but if you do have a FlexLM license server on premise, for example, and you want to run applications in the cloud that are going to need to check out those licenses, then you will need a DNS connection back to your on-premise. So that then the application can, see the license server where it is on-prem and go check out a license as needed.
Right.
Next question is, how do you manage user IDs? I think you did touch on that, Bill. Maybe just a comment on that again.
So yes, there were definitely different levels of user ID required. In the NavOps launch portal, that user ID information is using OpenID, so it can connect to ADFS or LDAP or other systems. So from NavOps launch itself, as you can see, it's pretty straightforward, connecting to existing identity management systems. When you're, say, running your, a Univa Grid Engine job, it works exactly the same way all Univa Grid Engine clusters work, which use the identity management configured in the operating system where Grid Engine is running. Again, that can be ADFS using, other tools, or it can be other types of authentication systems.
Okay, thanks, Bill. The next question is, can I use auto scaling?
Yes, I didn't demonstrate that today, but yes, you can use spot instances, and what happens there is you set your price and how many you want to, the maximum you want to the system to create, and it will go and maintain that sort of steady state number of spot instances in your cluster automatically.
Okay. Excellent. And the last question is, what communication is there between the Univa Grid Engine in-house instance and the Univa Grid Engine instance in the cloud?
Okay, that is a good question. When you are creating a hybrid environment, there is a networking infrastructure that must be set up between your on-premise network and the AWS network. And that's because you have to have that transparency as much as you can get between the on-premise network environment and the AWS network environment. Once that's set up, then the only thing that needs to be shared from the Grid Engine point of view is the nodes in the cloud need access to the Grid Engine configuration from on-prem. And that is set up through NavOps launch and configured using a command. And once that's done, when those nodes come up, they will join that cluster automatically on-prem.
Okay, excellent. Thanks, Bill. One last question we have is about the session being recorded. Yes, we are recording the session, and yes, we will be making it available for those that weren't able to see it today. But great question, and we're happy to be able to share it. We'll keep you updated, and I'm sure we'll be sending the communication out as soon as it becomes available. Oh, sorry, there is one more question in the chat. What is the turnaround time for a job releasing the nodes to the new job picking up same nodes?
So
I guess
you can decide using the automation. Yeah, you can decide in the automation engine how you want to run your cluster, right? And it's a very good question, because some people want they want to use Spot as an example. So that when those instances are no longer needed, just get rid of them and start another one. But some people are running nodes in the cloud where, again, once a job finishes on that node, another job can go to the same node. So they're really running a sort of minimal steady state cluster in the cloud environment. Again, that's all controlled by the automation. So you can decide within the automation, looking at particular sets of nodes and saying these ones are always going to be maintained, so they're never deleted, or they're deleted under different circumstances. That's how it's done.
Yeah, so ultimately it will as you said, depending on how you want the cloud to operate for you. If you want it to be totally dynamic and just allocating to jobs on an individual basis and then shutting machines down as soon as jobs finish, we can do that. If you want to persist a machine because there's more jobs coming, then really it's just as quick as the scheduler can pick up the next jobs from the queue, right?
Correct. In fact, it's very quick. Once those nodes are free, then other jobs go to them immediately.
Right, and that was the question. Okay, that is all the questions that we have from the audience. Thank you very much, audience, for making this very active and providing some great questions. Do we have anything else that we wanted to add, Bill or Rob?
I would just like to thank Amazon for hosting us today. It was a lot of fun, and enjoyed the questions from the people attending.
Yep, thank you.
Yeah. Thank you very much, everyone, and have a great day.